Hey guys, this is Miss Bolin, and today we're going to be going over our Factoring Quadratic Study Guide. Okay, we're going to start off by going over the quadratic equations that have a equal to 1. And this is where we are just factoring and not replacing the middle. Okay, so we just find two factors, and we need them to multiply to get negative 20, but then add to get 8. Okay, and we don't have to replace the middle section. So our two numbers, if we look at our calculators, which we can also do by plugging in this whole entire equation. Like, it doesn't matter which equation you're looking at, but you can just plug those in, and you can plug them in to find the factors. So if I wanted something to add up to be 8, but then multiply to be negative 20, I can just put this in my graphing calculator as y equals, and then I could do negative 20 divided by x. And that will give you a list inside your table, which you get to your table by doing second graph, and it will give you a table of x and y's. And inside your table, if you add these together, whatever numbers they're giving you, it will give you numbers that will add and multiply to get your two factors. So that's like a shortcut way of finding your two factors if you didn't know a number that multiplied to be negative 20 and then added to be 8. So my two factors are going to be negative 2 times 10, which is negative 20, and then negative 2 plus 10, which is 8. And I don't have to replace these with the middle. All I need to do is write my two parentheses and put a minus 2 and a plus 10. Okay, and those are my two factors. And I'm not replacing the middle this time because my coefficient in front of a is a equal to 1. So all of these, 1 through 4, I have a coefficient of 1. Okay, so let's look at number 2. So same thing applies. I can write my two parentheses, and I need something that would multiply to be negative 48, but then it needs to add to be negative 2. And so once I get those two factors, I just write them. So 6 times negative 8, and then 6 plus negative 8. And that will equal 2. I'm sorry, negative 2. Okay, so I can just write this down as n plus 6 and n minus 8. Okay, moving on to number 3. I need a number that multiplies to be 40, but then adds to be negative 13. Okay, so I know I'm going to have two negative numbers with this one because when you multiply two negative numbers, you get a positive, but when you add two negative numbers, you get a negative. So negative 5 times negative 8 gives me 40, and then negative 5 plus negative 8 give me negative 13. So I can just write it out as n minus 5 and n minus 8. Okay, next for number 4, I'm going to do the same thing. I need something that multiplies to be 35, but then adds to be negative 12. So my two factors for this one are going to be, again, two negative numbers. So negative 7 times negative 5, and then negative 7 plus negative 5. So b minus 7 and b minus 5. And notice for all of these, I use the same variable that they used in the initial problem. So b's for number 4, n's for number 3, n's for number 2, and a's for number 1. Okay, next we are going to go into bigger trinomials, and these are the trinomials that have a is greater than 1. So those are where we're going to replace the b. Okay, so all of these that you can see, you actually have to take out a GCF and replace the middle. Okay, so starting with number 5, I'm looking at number 5 and I'm like, okay, these are really, really big numbers. If I go and multiply 21 times 144 and I use the AC method, which that's, if I have A, B, C, that's multiplying this term times this term. And those are really big numbers. So what I want to do is make them smaller. So I'm going to divide all of them by something. So AC method. So I'm going to divide all of them by a common multiple, which here the common multiple is going to be 3. So if I divide all of these by 3, and remember, everything that I take out or everything I'm dividing by, I'm going to put on the outside. So 3, and then 21m squared divided by 3 is 7m to the second power. Negative 102m divided by 3 is going to give me negative 34m. And then negative 144 divided by 3 is going to give me a negative 48. So now these are smaller numbers that I can work with. 7 and negative 48, when you multiply them, is still a high number, but the only GCF or common factor that we could pull out initially is going to be 3. Okay, so we are going to find a number that multiplies to A times C. So this is 7 times negative 48, which that multiplies to be negative 336. And then we need numbers that add to be the middle, which is negative 34. So when I tried to come up with factors with my calculator, just dividing this out, like negative 336 divided by 12, negative 336 divided by 5, and I just kept going and going, and it took me forever to find the factor. So what I did was I took whatever factors I was trying to find, which is the negative 36, and I put that in my graphing calculator. So I put this in my graphing calculator as y equals negative 336 divided by x. And I looked at my x and y values to see which ones added to be negative 34. Well, that kind of took me a little while, but I did find them. And those two terms are negative 42 times 8, and that gives me negative 336. And then negative 42 plus 8. Okay, and these I have to actually take the factors and replace them in the middle because I have a number on the coefficient. Okay, so I'm going to copy my first term and my last term like usual. So I'm going to do 7m squared, but instead of putting negative 34m, I'm going to put this negative 42, my factor. And then plus 8m minus 48. Okay, and then like usual, I am going to pull out a GCF from that. So I'm going to put parentheses around. I'm going to bring down this 3 because I already had pulled out this 3 earlier. And then I'm going to find the GCF that I can pull out from each term. So the first term, I can pull out an m and an m. And then I'm also going to divide both of these, so it's like 7m, and then divide this one by 7m. And then I'm going to do the same thing, and I'm going to, and this is actually supposed to be, yeah, this is positive 8m. So I'm going to divide by 8 and divide by 8. And I can't divide by 8m because the 48 doesn't have an m attached to it, obviously. So I'm going to actually divide these. So you take them and divide them. The ones that you divided, so I put that I'm going to divide by 7m. Whatever I'm dividing by is going to go on the outside. So 7m, and I'm just writing all over this for right now, and I'll go back and kind of erase. So 7m, and then in parentheses, I have the m left over, minus 6, parentheses. So then over here, I divided by 8, so 8's going on the outside, and then what I have left is m minus 6, okay? And these should always match, keep that in mind, You should know that as a review. And then so my two factors are going to be the 7m on the outside. So 7m plus 8, and then m minus 6. Okay? And so you guys might think, oh yeah, that's our answer, but nope. We have to remember that initially we divided by 3. So I also have to put the 3 on the outside. So now this is my answer. So I have the 3 that I initially divided by, and then my 2 factors. Okay? And we won't have a whole lot of those on the test, but you will have, out of 25 questions, you'll have about 3 of those. So you need to make sure that you always pull out the GCF, put it on the end, and then you have your 2 factors. Okay, next. And if you need to go back to number 5, you can always go back to number 5. Hopefully you didn't write all over the place like I did. But next I'm going to do number 6. And number 6, if you look at it, like, those are not very high numbers like number 5. They're a little bit high, but we can still work with that, okay? So we're going to multiply the a times c, so 5 times 16. So that means we need a number that multiplies to be 80, but then adds to be negative 24, our middle number, okay? So you can either put this in the graphing calculator, and you can put it under y equals, and then we can put 80 divided by x, and then look at the second table. Or you can just look at them and say, hey, negative 20 times negative 4 gives me a positive 80, but then also negative 20 plus negative 4 gives me a negative 24, okay? So here we're going to have to take these and replace them in the middle, just because we have that 5 on the outside. So I'm going to copy the first term and the last term. So I have the 5x squared and then 16. And then I'm going to put those in the middle. And remember, I'm going to keep the x. So I'm going to make sure you put the x, because it has to be equivalent to what's in the middle. And then minus 4x. Plus 16. So now I'm going to break that down, figure out, what can I divide both of those? Well, usually you're just going to divide by whatever the term is up here. So I can divide both of these by 5x, divide by 5x, and then I can divide both of these by negative 4. Okay, so keep in mind, if I divide by it, if it's at the bottom, then that means it's coming out. So 5x comes out. Then when I divide 5x squared divided by 5x, that's just going to be an x. Then negative 20x divided by 5x, that's going to be a negative 4. And then next, I'm going to look, and I'll say negative 4x divided by negative 4. And I divided by the negative 4, so I'm going to bring out the negative 4. So then I divide, have an x minus 4. And yay, they match. So these two match. So my factors are just going to be the outside, and then you have the inside. So 5x minus 4 is one factor, and then x minus 4 is my other factor. Okay, moving on to number 7. Okay, number 7 is kind of large. You have the 18 times the 24. So we can look at these and say, what can I divide each of these by to make this smaller? Okay, so I'm looking at these, and 6 looks like a good number, and it actually works. Okay, so you're going to divide everything by 6. So you're going to be left with 6, and then what you have to factor after that is 3p, because you're dividing everything by 6, minus 13p plus 4. Okay, and I have to factor this. So I need something that multiplies to be 3 times 4, 12, and adds to be negative 13. Well, when they're numbers that are really close together, like 12 and 13, it's usually going to be that number and a 1. So they're going to be 2 negative numbers, obviously, because when you multiply them, it has to be 2 negative numbers to make that positive. So negative 12 times negative 1, and then negative 12 plus negative 1. Okay, so I have to take these and replace it with the middle, because that's how we do our AC method. Okay, so when I replace it with the middle, I copy the first term, 3p squared, copy the last term, and then I plug in those terms. So I'm going to have negative 12p, and then plus 1p. And that should be a negative. Kind of messed that up. Okay, now I put parentheses around these. And I can't forget, like I could just bring down my 6. Make sure I keep it with me. Okay, and then I am going to find what I can divide these by. So I'm going to divide by the coefficient, which the coefficient here is going to be 3p. So I'm dividing everything by 3p. So the first term I'm going to divide by 3p, and the next term I am going to divide by a negative 1. Okay, so I'm going to keep my 6, bring it down, and then I know that I divided by 3p, so 3p also has to come out, and then after 3p comes out, then when I divide this, I have a p, and then I have minus 4, and then I divide it by this negative 1 here, so I'm going to put the negative 1 on the outside, and then I have a p minus 4, okay? So now I have all of this. I have the 6 that's going to be part of the GCF of my 2 factors, and then my other GCF is going to be one of my factors, and then one of these matching terms. So the answer for number 7 is going to be 6, 3p minus 1, and p minus 4. So I included the 6 again because I initially divided by 6 to make it smaller. Okay? Okay, now for number 8, which I need more room. So I'm going to kind of erase this. Okay, so for number 8, these look like big numbers, but they're workable. Like 5 times negative 9 is going to give you negative 45, so they're not that bad. So you don't have to take the GCF. Sorry, that was totally the bell, but you don't have to take the GCF for this. So you can just do the AC method, something that multiplies to be negative 45, but then adds to be negative 12. Okay, 2 numbers that do that are going to be negative 15 and 3, and negative 15 plus 3. Okay, again, this has a 5 on the outside, so I'm going to copy the first term, and I'm going to copy the last term. And I'm going to take these and replace them in the middle. So I have negative, it's a big negative. So I have negative 15x plus 3x. And then I'm going to put parentheses around them and take out the GCF. So I can take a 5x out of both of these. And I can take a 3 out of the other parentheses, okay? So everything that okay, so going back, like you can divide by 3 here. Sorry, every number that I'm going to divide by, I'm going to take out. So it's going to be 5x goes on the outside because I'm dividing by it. And then when I actually divide this, I get an x minus 3. And then for this one, I divided by 3, so I'm going to put 3 here. And then I'm left with, again, x minus 3. So my 2 factors are going to be from the GCF, so 5x plus 3, and then one of these that match, so x minus 3. So those are going to be my 2 factors. Okay, next are my difference of 2 squares and then like perfect squares. So, and remember, like difference of 2 squares, when you have a difference of 2 squares, you can just take the square root of the first number and the square root of the last number. So difference of 2 squares, and these mean perfect square roots. So these are like so simple, okay? This means like I have 2 perfect squares. So this is a perfect square and this is a perfect square. So like the square root of 16 is going to give me a 4p. So square root of 16p squared is a 4p. Then the square root of 1 is going to be 1, okay? So it's 4p plus 1 and then 4p minus 1. Okay, so a difference of 2 squares. So you're going to have one that's positive and one that's negative. Okay, difference of 2 squares is like when your answer comes out to be the same thing, but one is positive and one is negative. When you have the same thing and one is positive and one is negative, that means that your middle value cancels out, right? And you only have 2 terms instead of like 3 terms, which we had for like number 10. Number 10, if you look at the first term and you look at the last term, both of these are perfect squares. So since they are both perfect squares, and then you still have a middle term, then the perfect square, so the square root of 9x squared is going to be 3x. So one of your terms is going to be 3x and the other one is going to start with 3x. The square root of 1 is going to be 1. Now when you're trying to figure out the middle, like do I put plus, do I put minus, what do I put? You have to think about, since you have a middle term, okay, your middle term is going to be kept. So it obviously can't be 1 plus, you can't put 1 plus, 1 is plus and 1 is negative because that will cancel out your middle term. So what you have to look at is, are both of these going to be positive or are both of these going to be negative? So since you have a negative and your 6 is negative, then they're both going to be negative, okay? And since you have 2 of the same exact thing, you can just write it as 3x minus 1 squared. And you can check this because when you refoil this, how do you get the inside term? Well, you check it by doing outer, which is negative 3x, and then the inner, which is negative 3x. And negative 3x minus 3x is going to give you the negative 6x. So if this term matches with your middle term up here, then you know that you're correct. Okay? Number 11 is the same thing. Okay? You have a perfect square for A and a perfect square for C. And then you have a negative in the middle. Okay? The square root of 4x squared is going to give you 2x. So one of them is 2x. And the other one is 2x in the beginning. Okay, so I have 2x and a 2x, and then the square root of 9 is 3 and 3. And I know both of these are negative because my middle term is negative. So I can just write out my answer as 2x minus 3 squared. So number 12 is just like number 9. You are missing a middle value. So when you write this out, these are perfect squares, so you'll have 2n minus 3. And then you'll have 2n plus 3. And one's positive and one's negative just because it's going to cancel out your middle term. All right, when factoring polynomials in standard form, you should always look for a GCF. Okay, that's a greatest common factor. That's like the number that you can divide everything by. Especially if they're like really big numbers. Like if you have an A term, a B term, and a C term that are really, really big. Okay. You also need to look for perfect square trinomials or the difference of 2 squares. Okay. So you put the difference of 2 squares. Okay. That's the cases where you can just take the square root. Okay, number 14 says, when factoring polynomials and A equals 1, the best method for solving is guess and check. So put guess and check. And guess and check just means pick 2 terms, like if I were to do number 1. So you're just going to pick 2 terms when A equals 1, and you're going to say, okay, what multiplies to be negative 20 but then adds to be 8? Well, you just guess and check. Negative 2 times 10. Does that equal negative 20? Yes. Negative 2 plus 10. Does that equal 8? Yes. So that's how you guess and check. Okay, we never officially put a name on it, but that's what it's called, guessing and checking. Number 15 says, when factoring polynomials where a is greater than 1, what are the two methods you could use? You could either plug it into your graphing calculator, or you can use the AC method. All right, number 16, it says a rug has an area of 2x squared plus 19x plus 35. So this is like your warm-up problem where you have to take this and you have to factor it to find your two, you have to factor it to find your two binomials. Okay, and you're going to use the AC method because you have a 2 at the outside. So you want to find something that multiplies to be 70, but then adds to be 19. Okay, so we're going to find those two numbers. So I'm going to copy the first term, and then I'm going to copy the last term. Okay, and then I'm going to look and say, where's the best place to put 14, and where's the best place to put 5? So am I going to put 5? I'm glad you guys think that's funny. So am I going to put 5 in the front? No, because I cannot divide. I can't do 2 divided by 5. So what I'm going to do is I'm going to put the 14. So I put 14x in the front and plus 5x. Okay, and now I'm going to pull out the GCF. So I'm going to divide each of these. So I'm going to divide by the first term. So 2x and then 2x. And then I'm going to divide the next one by 5. Okay. So I'm going to, anything I divide by, I'm going to put on the outside. So 2x. Then I have x plus 7. And then 5 goes on the outside. And then I have x plus 7. So my two factors for this will be the outside, which is 2x plus 5, and then my insides that match, which is x plus 7. So you have to look in the problem and figure out, if it tells you that the length is 2x plus 5, it gives you the length, okay? So I already knew this was the length. What they don't give you is your width, okay? So the other factor that's not listed up here that was not originally in my problem is x plus 7. So I know that this is going to be my answer. So that's going to be the width. So I'm going to make an additional video going over your word problems, and it will be posted along with this video.